Raspberry Pis are incredible tools, and with some scripts, you can do some amazing stuff. But manually running scripts, nobody wants to do that. Which is why today I'll show you how to use systemd to fully automate any Bash or Python script so it starts at boot and runs like a real service. That being said, let's go engineer some stuff. For this project, we will be creating a directory called services_demo and cding into it, and doing a pwd shows we are in our working directory of our project. In our services_demo directory, using your text editor of choice, let's make a bash script called usb-event-logger.sh. So this simple bash script starts by logging the date that our service started to both a log file and journal. Then udev-adm, our udev management tool, monitors for USB events, and while there are USB events occurring, we'll log those to our log file and journal. The cool thing about logging to both journal and a regular log file is it gives us flexibility. So we can monitor our service via journalctl, but also we can do advanced text parsing on our regular log file if we wanted to. And before we write our service file, let's do a chmod +x usb-event-logger.sh to make our shell script executable. First part of creating our service file is to go into the right directory, so we'll cd etc systemd system. This is where all of the services are stored. Back to our text editor of choice. To make the service file, we'll have to do this with sudo, so this way it can access the correct write permissions for this directory. Now, starting with breaking down our service file, jumping into the unit section, this describes what the service is and when it should start. Description is the human readable summary that shows up in systemctl status or journalctl. In our case, it's just USB event log. After, tell systemd what needs to be ready before this service starts. Here I use multiuser.target, which basically means wait until the system is fully booted, networking up, shell available, etc. Next, we're going to jump to the service section. This is the core of the unit file. It tells systemd how to run the script, which user runs it, the exact command, and how to handle restarts if that was to occur. User sets which user the script should run as. In my case, it's SJR. You'll need to change this to your user. And if your script needs root, you can set it to run as root. Just be careful with that though. Exec start is the full path to the script we want to run. It needs to be the full path, not relative path. Restart always tells systemd to bring the service back up automatically if ever were to crash or exit. And restart sec, likewise, in this case is going to be a 2-second delay so it doesn't keep restarting instantly in a failure loop and just keeps spamming our log, which would be bad. Finally, there's the install section. This tells systemd when the service should start automatically during the boot process. Wanted by multiuser.target means as soon as the system reaches its normal multi-user mode, which we just covered above, again, networking ready, shell up, etc., start the service. Although important note, this section doesn't actually activate auto start by itself. We still need to run sudo systemctl enable USB event logger.service. That creates the right system link so the service really does start on boot. And then sudo systemctl start USB event logger.service will start it immediately and we can check its status from there. And here, doing our systemctl status on our service, we can see it's active, it's enabled, and it's running as suspected, and we see the initial log lines from journalctl saying that USB watcher is started, and then we can start processing the in and out events of our USB. By doing journalctl-t and then the name of our service, in this case USB event logger, and -f, we'll be able to monitor our service. For example, I'm pulling a USB drive in and out of the USB ports on my Raspberry Pi, and as I'm pulling out and inserting my USB into the Raspberry Pi, we can see that it correctly is monitoring the udev events for insert and removal, and we get all the cool other info that we can see about that it's a USB drive, even the manufacturer, and I also have a USB dongle for Ethernet that I'm pulling in and out, and as we see that, we can see that also will tell us exactly what device it is and all the cool info about that. To prove to ourselves that the script starts at boot, let's reboot the Pi with sudo reboot, and once it comes back up, let's quickly check the uptime to prove it has been rebooted, which we can see it has. Then, doing systemctl status USB event logger.service shows us it's running active and enabled and been up for a little over a minute. Running journalctl-t USB event logger-f and pulling my USB drive in and out of the Pi shows just like earlier, the service came up at boot, can be monitored, and is logging our USB events exactly as we want. What's cool about the systemd service method is we can also automate a Python script to start on boot. Here we have a script called cpu_temp.py. It's a basic single function script that gets CPU temperature using vcgen cmd measure temp command. Then in an infinite loop, we read the temperature, print its value every 5 seconds while writing it to journal, which we can then monitor coming right up. Before we jump into making our service, quickly let's make sure our script works. I've sped up the recording, but every 5 seconds our CPU temperature is being printed. Without completely repeating myself from our previous service file that we didn't bash, we have a basic description. We want to start after reaching multiuser.target. We'll run it as SJR, which is my non-root user. Always restart with a delay of 2 seconds between those restart attempts. And for install, also making sure we are in multiuser.state. The biggest difference is in exec start, where we are explicitly pointing to our Python 3 interpreter and then pass in our Python script with the full file path. For our service to run, we will execute sudo systemctl daemon reload, followed by sudo systemctl enable --now cpu temp.service to have our service run right now and at boot. I will speed up the footage, but by looking at the timestamps on the left-hand side in journalctl for our service, shows our Python script is outputting our CPU temp every 5 seconds, which is exactly what we want to see. I will confess I almost forgot to show the output of the status of our service. Thankfully, it's looking good, running active, enabled, and up for about 7 minutes. And that is how you turn a bash script or a Python script into a systemd service. Let me know what systemd services and scripts you guys plan on automating. If you have any questions, let me know down below. Always happy to answer them. Like and subscribe, and stay tuned for more videos. I've been Sam the Engineering Man, and I'll catch you all in the next one.